Hey guys, so welcome back to our next class of Catalyst concepts. Let's dive into the topic straight. So last time we looked at what are different applications that we can have for total internal reflection. Today we'll look at a small activity to see what refraction through a glass slab would look like. Okay, so this is a rectangular glass slab if you see. So I need you to follow my steps quite carefully to understand what is happening in this activity. Okay, so for this activity I'm going to need a paper, a glass slab, and I'm going to need some stationery, basically pencil, scale, sharpeners. I also need a protractor, and I need some sort of pins. So any type of pin will work. Thumb pins would do best. I'm going to make do with these bent pins that I have. Alright, so now for this activity, what I'm going to do, the first step is, let me fix where I'm going to keep my glass slab, and that is right here. So I'll just draw an outline to make sure that I know where my glass slab is supposed to be placed. Okay, perfect. Now I'm going to remove this glass slab here. I think this edge is a little twisted, but that is okay. Now on this glass slab, I'm just going to name it A, B, C, D for the four corners of the slab. What I will do is I'm going to draw a perpendicular to this glass slab, maybe on one of the longer faces, A, B and C, D. Okay, so if I have to draw perpendicular, draw it at 90 degrees over here and just connect it with the glass slab, right? Alright, so first I'll mark the point here. From there, just a 90 degrees line. Yeah, perfect. It's over here. Now we just connect these two like this. Right, now this is basically my normal line. So this is my normal. What I want to do is normal to this surface I'm going to draw an incident ray. Okay, and that incident ray is going to be incident at this point over here. Alright, so now let me pick any angle of incidence. We can pick any. I'll take let's say 30 degrees. Okay, so I'm going to take a 30 degree angle, so that would be 10, 20, 30. Right, basically 30 degrees from this normal. Now I have my 30 degree line, so ideally I should take a scale and connect it like this, right, point to point. Okay, I'm going to talk about this 30 degrees angle of incidence going this way. Alright, now I am going to put back this glass slab where I took it out from. Make sure it's exactly in position, like so. It's a little tricky, but I guess I got it. Perfect. Now my glass slab is in position. So what I'm going to do, I'm going to place two pins on this side and look at it from the other side. Okay, so basically I can either do it from here and look from there, or I can just flip the paper around. So it's easier for me to look from this side. I'll simply flip it around like this. Okay, perfect. I guess my line drawing came a little bit off there, but it is aligned on the other side, so that is okay. It's more straight. Now I'm going to fit two pins on this incident ray over here, right? You can see the incident ray, right? So I will put two pins, one like that and one bit behind it like this. Okay, just to see the direction of these two pins coming exactly in that line. For the next step, I'm going to look through this side of the glass slab from the bottom. Okay, I will look through here and I'm going to mark the pins based on how I see them through this side. I'm going to try to align them in the same straight line. Okay, all right. So you can see it. Now for me, from down here I can see them in alignment like this. Right, I'm going to attach a picture of what it looked like down there so you can also see what it was, and I try to fix them exactly along the straight line. If you clearly see from the top, they are not exactly aligned. Right, this line goes this way, but this line is actually coming from somewhere else. So what I'm going to do, I'm going to remove these pins from here so the paper doesn't move, and I want to connect them and touch them to the this drawing, right? So that should be something like, here are the two holes from the pins. So I'm going to connect it something like this. All right, now that I have connected them, what I'm going to do from this point, let me draw the normal also. So I'm going to make this normal exactly. Okay, where are the points? Here and here and here. So yes, so now draw the normal. This would be my 90 degrees. Okay, now what I can measure here is what is the angle between this normal. As we know, since it's 90 degrees, this is normal is going to make 90 degrees here also and here also, right, on both the faces. But what I want to see is what is the angle between this normal and this ray that we saw coming out. Okay, so if you see, it's about the same from 90 to 60. That is basically, this is also 30 degrees. So basically the light coming in at 30 degrees is also exiting at 30 degrees. But if I see, if I draw a straight line from this ray, right, pointing out like this, right, it's not meeting this line, it's not meeting that incoming ray. It is actually, if you extend it, you'll see it's actually kind of going parallel to it. Even this ray, the one that was incoming, if I extend it, I'll see that it is parallel to my outgoing ray. This is my refracted ray, this is my incident ray. This is nothing but my angle of refraction when it is coming out of the glass slab. So basically, if I see, when the light entered here, from here it went like this, right, it hit here, then it bent and went all the way till this point here, and then when it came back to air, again it got back its 30-degree angle. So if this is my angle of incidence, this will actually be my angle of emergence, and this is nothing but my angle of refraction, because it was supposed to be like this, but it has bent over here. So that's one easy way to find the angle of refraction. And as of now for me it's about 14 degrees, 14 or 15 degrees. It's hard to find exactly, but it's roughly I think 13 degrees actually, yeah. So my angle, my ray of light refracted by 13 degrees, it went in, again got refracted back. If I measure this also, it will be about the same, 13 degrees. So the incoming outgoing angles are same. That is why the lines are all parallel, whether they go in and they come out. That's proved by this angles and these two angles. Now this phenomena is what we call as lateral shift. Okay, lateral shift. This lateral shift is nothing but when light is incident on another medium and again goes back to the original medium, there will be a slight shift in how it goes. That shift is nothing but the lateral shift. For us it's signified by this line, because it shifted this way and then continued going out like that from the slab. That is called lateral shift. So I hope you understood the activity. You can actually remove these pins also, and this is the last topic pretty much for this chapter. If you have any doubts, questions, you can drop it in the comment box below. And yes, I will see you in the next class. That's it for today.